Hi everybody, in this video I'm going to be going through the notes for lesson 1.3, which is all about words patterns. Let's start with what exactly is a words pattern. Sometimes we need to find a pattern by reading a story. There are some key vocabulary words to look for, so we're going to go over those words and then we're going to try to find them in the stories that we read as examples. Let's start with keywords for your input labels. You might remember from the previous lesson that we need to make tables and graphs of our patterns, so we need labels for our inputs. When you're reading a story, you're going to look for the words each or every or per. These words and whatever comes after them, so each week, each hour, every day, per figure, these tell you what the label should be for your inputs. Now, there's also keywords that tell you what your first input should be, that starting number. If you ever see the words starts with or at the beginning, that is a clue that the first number of your input is a 0. So when you make your table, you should put a 0 as the first input number on the left side of the table. And then there are some keywords for the pattern. A pattern is how the amount is changing by. The first keyword is doubled, which means multiply by 2. The next one is tripled, which means multiply by 3. And the last one is half, which means divide by 2. So after you have a starting number and a pattern, you're going to have to find all the other numbers. So it's really important to get the pattern right. Let's do an example. The math team is selling cookies to raise money for the next meet. They start the day with 324 cookies, and each hour the number of cookies they have left are divided by 3. First, let's look for some keywords that might tell us our input label. So I'm looking for the words each or every or per. I'm noticing it says right here each hour, which is a key word. So I'm going to write the word hour as my input label, and right away I'm going to write it on the table and the graph so I don't forget. Then I'm going to ask myself, what is the output label? Now remember, the output label is the number of things you're counting, and it looks like we're counting the number of cookies. So we're just going to write the word cookies here as our output label, and right away I'm going to label my graph as well so that I don't forget to do it later. Next, we need to figure out the first numbers in our tables. So it says here they start the day with 324 cookies. Again, that's one of those keywords we talked about, start the day with. That means before any time has gone by, before any hours, we already had 324, which means my first starting number will be 0, and the number of cookies would be 324. In order to fill in the rest of the table, I need to look for a pattern word. So a word like adding or subtracting or multiplying or dividing. It says here that the number of cookies they have left are dividing by 3, which means the number of cookies to get the next number, I'm going to need to divide by 3. So that means my numbers are going to be 108, 39, 13, 30, what am I doing? 36, I was like, this feels weird. 36, I'm sorry about that, 12, and 4. I'm just going to keep dividing by 3. Now, if I go back to where it said each hour, it just said each hour, which means it's going up by 1. So my next hour would be 1 more. 1, 2, 3, 4. Okay, now I'm going to graph those values. So 0, 324, 1, 108, 2, 36, 3, 12, which is going to be like here, and 4, which is going to be really small. Right away, I can see that my graph is not a straight line, it's a curve. So I'm going to make sure I land that plane nicely so it doesn't hit the ground. Now, in terms of the pattern, if I said, is this pattern increasing or decreasing? Again, this is a review of yesterday, but the answer would be that the pattern is decreasing. And there's two reasons. The first reason is that there is a dividing pattern, which division is always going to give us numbers that get smaller. And the second reason is that there is a downhill graph. The graph is definitely going downhill here from left to right. The next question is this linear or exponential? And the answer would be exponential because this is a dividing pattern and multiplying and dividing always give us exponential graphs. And the other reason is because the actual shape of the graph is an airplane graph. Let's do another example. So, on the second day of sales, there were 400 students who still needed to pre-order their books. Each day, the number of students who still need to pre-order their books was cut in half. The first thing I'm going to do is look for one of those keywords that tells me my input label. So each or every or per. It says here each day. That means that my label here is going to be days. And I'm right away going to label my graph as well, days. Then I'm going to try to figure out my output label. So in other words, what am I counting? I'm counting the number of students, which means I'm going to write students here. And I'm also going to write students here. Then I need to figure out my numbers. So in order to do that, I'm going to need a starting number. Let's look for some of those keywords about starting. It says, on the second day of sales, there were 400 students. Well, I might not know how many there were on the first day, but I know how many there were on the second day. So my starting number here will be 2, and my students will be 400. And since it said each day, which means 1, I can fill in 3, 4, 5, and 6 right away for the days. I also need to figure out a pattern word. It says here that the number of students who need to pre-order their books was cut in half. One of our vocab words said that half means divide by 2. So I'm going to have 200, 100, 50, and 25. Now I'm going to go ahead and make my graph. So 2, 400, 3, 200, 4, 100, 6, 25. Again, this is going to be a curve. So now, just a quick review from yesterday. This is decreasing, and it's decreasing because it's a dividing pattern. And because it's a downhill graph. It's also going to be exponential because, again, it's a dividing pattern. And because it's an airplane-shaped graph. Now, just like one last thing, just like there are problems where I give you words and you have to figure out what the words mean, the second goal for today is going to be to describe a pattern in words. So you're going to look at a pattern and tell us what's happening. Now, there are two things you need to talk about. The first thing is you need to tell us what is changing and how much it is changing by. An example would be like here where it said each day the number of students who still need to pre-order their books was cut in half. You also need to tell me how often it is changing. So each day, each hour, you're going to have to use a word like each or every or per in order to tell me how often it's changing. It's usually easiest to do this step where you describe the pattern after you look at the table. So for example, in this problem, I have a partially filled in table. I'm going to fill in the rest of it. On the left side in the days column, to go from 3 to 5 and 5 to 7, we are adding 2 every time. That means that this number would be 9, and in order to go backwards, we would do the opposite, so we would subtract 2, which is 1. On the right side of the table, it looks like to go from 4 to 7 to 10, we are adding 3 each time. So if I add 3 again, I get 13, and to go backwards, we would do the opposite, which is subtract, so we get 1. Now we have a filled-in table, and we also have a pattern. Now, when we describe a pattern, we always go in the down direction for the table. So this +2 and this +3 are numbers that are going to really help us here. Let's start with what's changing and how much. 3, it's +3, and it's the inches of rain. So we would say 3 more because the operation was plus, inches of rain. And then we need to describe how often. So +2 is the days, so we would say every 2 days. Now you'll notice I'm using the word each or every or per here because that's the input. Is this an increasing or a decreasing pattern? Well, if I'm going in the downwards direction, it's increasing. So it's increasing because in the forwards direction, going downwards on the table, we have an adding pattern. Now, you might remember that in the past, we've sometimes said there's actually a second reason. It's because you have an uphill graph. But we don't have a graph here. We're not looking at a graph, and so we don't need to talk about graphs in our reasoning since we are not reasoning using a graph. We're reasoning using a table. Next, is it linear or exponential? Well, again, it's an adding pattern. So if we did graph it, it would make a line. That means that we have an adding pattern as our reason, but we can't say that it's because there's a line graph because we're not looking at a graph. Last problem of these notes. Use the graph to make a table. So this time we're kind of going backwards. We're starting with a graph and we're going backwards instead of starting with a table and going forwards to a graph. Let's start with the labels. These input labels go on the left side of the table. So I would write time in days here. And the output labels go on the right side of the table. So I would write number of flowers here. Then I'm going to give the points from the graph. Now you'll notice there isn't a line drawn, which is totally fine. It's okay for a graph to sometimes just be made of dots, but no matter what, we always read a graph from left to right. So when we start listing our points, we're going to start on the left side and we're going to end on the right side, which means this guy goes first. So the points would be 1 for the time and 3 for the number of flowers. The next point would be this one, which is 4 for the time and 5 for the number of flowers. And the third point would be this one, which is 7 for the time and 7 for the flowers. Now you'll notice we didn't finish the table. So let's look for a pattern and see if we can finish it using the pattern. On the left side, I'm noticing that these numbers are going up by 3 each time. So if I continue that pattern, I get 10 and 13. On the right side, I'm noticing that these numbers are going up by 2 each time. So if I continue that pattern, I get 9 and 11. Now again, it's usually easiest to do everything else once you already have the table made. So if I say to you, please describe the pattern in words, what that means is tell me what's changing and how much it's changing by and how often. So what's changing here is our number of flowers. And how much? Plus 2 means 2 more. So we would say 2 more flowers. How often? Well, our pattern for our time was a +3. So we would say every 3 days. Now for increasing and decreasing. So I'm looking at both the table and the graph, and I'm noticing that there's a plus pattern and an uphill graph. That means it's going to be increasing. So we would say that this is an increasing pattern because we have an adding pattern also because we have an uphill graph. Next, in terms of linear or exponential, we're going to say we have a linear pattern. And again, linear is when we have plusing or minusing, and exponential is when we have multiplying or dividing. So we're going to say because we have an adding pattern and because we have a line graph. Even though there's no line on the graph, the points are actually in a line. We just didn't draw it in. And so we're done with this problem. Thank you all so much for watching today's notes, and thank you for taking great notes. And I get started on your homework now.